Welcome back to Space Science Tech, a channel dedicated to bringing you the latest in science and technology. In this cybersecurity tutorial, we will take a closer look at Bash scripting and how we can harness this simple yet powerful scripting language to automate tasks on our Linux computers. Bash, short for Bourne-Again Shell, is both a shell program and a command language, originally released in 1989, and is the default login shell for many Linux distributions. Bash is a command processor, where users input commands in a shell terminal to execute various tasks. Bash also supports the execution of commands from files, known as shell scripts, facilitating automation. Shell scripts allow for a sequence of Bash commands to be combined together in a single file to achieve more complex tasks than a simple one-line shell command, and are especially useful for automating sysadmin tasks such as backups, updates, and network scanning. In this video, we will look at a couple of ways in which we can harness the power of Bash scripting to automate IT and cybersecurity tasks. We shall begin by creating a new directory where we can store our Bash scripts. Create a new directory using the make directory command. Using the cd or change directory command, we can change the current working directory to the newly created directory. Here, we will use gedit to create and edit our Bash scripts, but feel free to use any text editor you are comfortable with, whether that be Vim, Nano, or the Nice editor. For our first script, we will automate the process of updating and upgrading our Linux system, as well as removing any unnecessary applications and files. Each Bash script begins with a shebang, #bang/bin/bash, which specifies the path to the Bash interpreter. This tells the system which shell should be used to execute the script. In the first section of the code, we combine the sudo apt-get update and sudo apt-get upgrade commands. These must be run in this order because update refreshes the package index files, allowing the system to know about the latest versions of packages, while upgrade actually installs the available updates for the packages on your system. The tacY flag is added to automatically answer yes to any prompts during the upgrade process. In the next line, we use sudo apt-get auto-remove to remove any unnecessary packages, typically old libraries that are no longer needed, and sudo apt-get auto-clean to clean up outdated package archives. Finally, we end the script with the exit command to ensure the script terminates properly once all tasks are complete. Make sure to hit save before closing the script. We can see that the update.sh file is now in our directory with the ls command. Before we run the script, we must modify it using the change mode command, followed by a +X to allow ourselves the ability to execute the script. Now we can run the update.sh bash script by typing // and then the name of the script. This process may take a few moments to complete. In our next example, we'll create a Bash script that pings every IP address within the range of our local network. To begin, we need to identify our private IP address. You can do this by opening a terminal and typing ifconfig. We'll use this IP information to target our network. Note that this script is intended for use in a controlled environment where you have full permission to scan the network. We'll create our script using gedit, but feel free to use your preferred text editor. Start by adding the shebang, #bang/usr/bin/bash, which specifies the path to your Bash interpreter. Next, we'll create a for loop that iterates through the range of IPs from 1 to 254, representing the last octet of our IP addresses. Within the loop, we'll use the ping command with the tac-c option, which sends a single ICMP packet to each IP address in the range. For the first 3 octets, we'll use the base of our class C private IP address, and the last octet will be substituted by $IP, which is the current value from the loop. Since we only want to capture responses from hosts that are up, we pipe the output to grep 64 bytes, which filters out the responses that indicate a successful ping. Finally, to clean up the output and display only the responding IP addresses, we use cut to extract the IP address from the response, followed by tr to remove the trailing colon. We also add an ampersand to run each ping in parallel, making the script more efficient. End the script with the done command to close the loop. Be sure to save the script before closing, then modify it using the change mode command, followed by a +X to allow us the ability to execute the script. Now we can run the ping.sh bash script by typing // and then the name of the script. This will return a list of all the active hosts on our network. In our third example, we will create a bash script to automate log analysis. This script can be used to regularly check logs for suspicious activity, such as failed login attempts. The Linux authorization log file, or auth.log file, is located in the /var/log directory on Debian-based systems. This file contains a record of all successful and failed login attempts, sudo usage, and other security-related events. Create the bash script, adding shebang and the directory path to your bash interpreter, which should be /bin/bash. Next, create a variable called log file and have this variable point to /var/log/auth.log. Followed by sudo grep failed password, as we are only concerned with failed login attempts. Include the variable we just created and pipe the output to only include the last 10 entries using tail tac10. Save and close the script, then modify the script by typing change mode +X and the name of the script. This will allow us to execute the script by typing / followed by the name of the script. Since we do not have any failed login attempts to show here, let us launch PuTTY from our Windows host machine and use it to set up an SSH connection to our virtual Kali Linux machine. PuTTY is a free and open-source terminal emulator, serial console, and network file transfer application, as well as a SSH and Telnet client. It was originally created by Simon Tatum for the Windows operating system and released in January 1999. You can download the latest installer from putty.org. Click on the Download PuTTY hyperlink. Since we already have PuTTY installed on our host machine, we will not cover that entire process here. When you click on the installer, Firefox warns us that the installer is an executable file that may contain viruses. Fortunately, we can verify the checksum of the PuTTY installer using the checksums provided on the official PuTTY website. Cancel the installation and scroll to the bottom of the PuTTY download page to the checksum files section. Choose between the 4 options. In this case, we will use the MD5 checksum. Open Command Prompt and move to the Downloads directory the same way that you would in Linux, by typing cd downloads. Be sure to capitalize downloads, as the change directory command is case sensitive. Verify the contents of the downloads directory using the dir command. Copy the name of the downloaded file and right-click the name to load it into memory, then type certutil tac hash file and paste the name of the installer by right-clicking on the highlighted file name and then right-clicking again behind hash file. Finish the command with the appropriate checksum type, in this case MD5. Highlight the return value and press Ctrl+C to copy the value. Click on the Firefox page and press the Ctrl+F keys to search the page. Paste the hash value by pressing Ctrl+V and hitting Enter to search. If the value returned by certutil does not match the checksum provided here, then this could suggest a compromised download, or perhaps user error. Once you have verified the checksum, click on the PuTTY installer. This time, when warned that the executable might contain viruses, click OK to allow the installation to begin. Since we already have PuTTY installed on our host machine, we are given the options to repair or remove PuTTY version 0.81, which is the version currently installed on this machine. Install PuTTY if it is not already installed. Returning to our virtual machine, we can grab the IP address of our VM using the ifconfig command. We will need this information for when we launch PuTTY on our host machine. Now that we have the IP address of our virtual machine, return to the host machine and launch a new instance of PuTTY, where we will intentionally fail in our attempt to SSH our way onto the virtual machine hosting the log analysis script. Enter the IP address of the virtual machine, ensure that SSH is selected and click Open. PuTTY failed to connect to our virtual machine because we have yet to install the SSH server application on the VM. Go back to Linux and in the shell terminal, open another tab and type sudo apt-get install OpenSSH server. If we try using PuTTY again, we will get the same network error as in our previous attempt. Before we can connect to our VM using PuTTY, we must also start and enable the SSH service on our virtual machine. We can do this by entering the following commands: sudo systemctl start SSH and sudo systemctl enable SSH. Launch a new instance of PuTTY and enter the IP address we previously obtained using the ifconfig command. Enter the username, and when it asks for the user's password, we will intentionally enter the wrong password 3 different times before entering the correct password on our 4th attempt. Now, we can return to Kali and run our bash script once again. Notice that we now have 3 failed login attempts for the administrator account. In our final example, we'll create a bash script to automate network traffic capture using tcpdump. tcpdump is a powerful command line tool for capturing and analyzing network packets. It monitors TCP/IP and other traffic passing through the network interfaces of your system, making it invaluable for troubleshooting and network analysis. Captured packets can be saved to a file using the TACW option in tcpdump. Once the capture is complete, you can load this file into Wireshark, a graphical network protocol analyzer, for more detailed analysis. Wireshark provides an intuitive interface for filtering, inspecting, and decoding packet data. Using Wireshark, we can delve into the captured network traffic, identifying potential issues such as latency, dropped packets, or even malicious activity. This combination of tcpdump for capture and Wireshark for in-depth analysis provides a comprehensive approach to network monitoring and diagnostics. create a new bash script, this time naming it capture_traffic.sh. Start with the shebang and path to your interpreter. As this script will be used to capture network traffic, create a variable called interface, which will be set to ETH0. Create another variable, called output file, and name it capture_$, open parenthesis date plus 5f_%t close parenthesis .pcap. Next, we want to use echo to write starting traffic capture on $interface ellipsis. Then sudo tcpdump tcpdump $interface tac w $output_file. Lastly, echo traffic capture save to $output_file. Don't forget to add execute privileges using the change mode tac-x command, and then run the script by typing sudo./capture_traffic.sh and pressing enter. This script captures network traffic on the specified interface and saves it to a .pcap file. To stop this script, you can press Ctrl+C, which sends a termination signal to the shell terminal, stopping the tcpdump script in the process, saving any collected traffic to the specified .pcap file. Go ahead, try opening the .pcap file with a text editor. Unless you've secretly turned into a magical AI genie, it'll probably look like a digital soup of pure gibberish. Instead, fire up Wireshark. Just click File, then Open, and find your saved.pcap file. Wireshark will transform that cryptic data into beautifully organized packets, ready for you to filter, sort, and analyze like a pro. And that concludes the bash scripting portion of this tutorial. If you found this video informative and would like to see more cybersecurity tips, tricks, and hacks, be sure to like, share, and subscribe to Space Science Tech. Don't leave yet, my fellow code slingers. In the final chapter of this tutorial, we will take a closer look at the Cron daemon and how we can tame this beast and harness its powers to automate our bash scripts. As this is a tutorial on automating IT and cybersecurity tasks using bash scripting, we must take a quick look at the Cron command line utility, also known as Cron daemon. Cron is a time-based job scheduler which comes installed on all Unix-like operating systems, including Kali Linux. The Cron daemon runs in the background and automatically executes tasks, called cron jobs, at specified times and intervals. As noted, we can use this utility to schedule jobs, also known as cron jobs, that can run periodically at fixed times, dates, or intervals. You can create cron jobs using the cron tab, short for cron table, which is a file that lists all of the scheduled jobs and their timing instructions. You can learn more about cron jobs by visiting crontab.guru, then scroll down to where you see the examples hyperlink. The examples page provides an impressive variety of examples to choose from, ranging from every minute to once every year. The important thing to take away from these examples is the format used by crontab to schedule jobs. There are 5 columns used to schedule cron jobs: minute, hour, day of the month, and day of week. In this example, we will schedule our cron job to start every time the system boots or reboots. To do this, we will take a slightly different approach. As system reboots can happen any minute of any hour, 7 days a week, it will be impossible to account for this using the typical approach to scheduling cron jobs. As you can see here, in addition to manually setting the minute, hour, days, and months, we can use at yearly, at monthly, at weekly, at daily, at hourly, or at reboot when scheduling our cron jobs. If we were to reboot our virtual machine and run the cron job now, the update.sh script will not work properly. Running scripts with sudo commands in a cron job will run into issues because the sudo command typically prompts for a password when executed, and since cron jobs run non-interactively, you won't be able to enter the password manually, preventing the script from completing successfully. Never fear, my intrepid code slingers, there is a simple workaround. We will configure sudo to run the necessary commands without prompting for a password by editing the sudoers file. Be cautious when editing the sudoers file, as incorrect edits may lock you out of sudo access. In a shell terminal, type sudo vi sudo and add the following rule at the end of the file, replacing username with your actual username. This tells sudo not to ask for a password when the user runs any of the commands specified. Only allow passwordless sudo for the specified commands to avoid introducing potential security risks. Save and close the sudoers file. Consider testing the passwordless commands by manually running sudo apt-get update, upgrade, auto-remove, and auto-clean in a different tab before creating the cron job. This will allow us to confirm that our changes to the sudoers file are working properly and that we can run our script 300 seconds after the VM has rebooted. Now we are ready to create our cron job that will run the update.sh script each time our virtual machine reboots. To open the cron tab, launch a shell terminal and type crontab tac-e, press enter. In this example, we will create a new cron job that will execute our update.sh script every time our Linux machine boots or reboots. Since we do not want this script to execute immediately, we can set a delay of 300 seconds. This will allow time for our VM to fully boot before the cron job kicks off. Check to ensure that the cron D service is enabled by typing sudo systemctl status cron.service and pressing enter. With our test complete, it is time to reboot our system and check the syslog to see if our cron job was a success. Login, open a shell terminal and type sudo grep cron/var/log/syslog. Enter the sudo password and press enter. Here, we have our cron job at the bottom of the list, with a timestamp of just a few minutes prior to the recording of this clip. This concludes our journey into the fascinating world of cybersecurity automation. For those of you who followed along, we only just scratched the surface of what's possible with bash scripting and cron jobs. In this tutorial, we began with an overview of bash scripting, showing how to automate tasks with simple scripts. We covered several examples, including updating and upgrading a Linux system, creating a network scanner using ping, analyzing log files, and capturing network traffic with tcpdump. Along the way, we explored useful tools like PuTTY for remote connections to virtual machines, learned how to verify file integrity with certutil, and examined how to open and analyze packet capture files using Wireshark. We also covered advanced topics such as editing the sudoers file to allow specific commands to run without a password, and we wrapped up with an introduction to the cron daemon, showing how to automate tasks using cron jobs. If you found this tutorial helpful and want to dive deeper into the power of Linux automation, be sure to like, share, and most importantly, subscribe to Space Science Tech. Thanks for joining us on this journey.